Yay, go next. Or?
Perfect. Finally.
Yay.
Now I just need to know how to make this bigger for you.
Technical issues at a technical conference. Who would have thought? Without further ado, this is Christian Witz. He's a local Capetonian, and he's going to be speaking to us about the cap theorem of humans.
Yeah.
Thank you.
Hi, all welcome. Sorry about the delay. My laptop didn't want to work. Yeah, welcome to DevOps Days Cape Town 2017. Glad to see you. Although I would prefer this room to be empty because honestly, this is the first time I've spoken at a conference for anything. So I'm a little nervous. Please bear with me if I pause and cry. So, what started off about months ago while I was having a beer was, what if we could tie computing theory to people and teams, and that's the topic of this talk, is the cap theorem of humans. So while I was ideating on this, I was listening to a lot of audiobooks on management theory, being a first-time manager, which I was kind of forced to, if you will, to learn more soft skills required to lead people and organizations and communicate effectively with others. Like, as you can see, I've only been a manager for 6 months. I've been working professionally in the industry for about 13 years and spelunking on code for close to about 30 or so. You can find me pretty much everywhere as Christian Witz, so GitHub, Twitter, LinkedIn, Instagram, most importantly the ZATech Slack group. You can find me around. Ping me if you want to chat about anything. I'm generally happy to help wherever I can. So, brief outline of the agenda. First going to cover the cap theorem and then how humans differ in that context, and then go through some methods that I feel are good starting points and how everyone can at all levels be leaders, and some simple steps to aid in inventiveness and creativity in this regard. So, quick recap of the cap theorem. So consistency is defined obviously as every read receives the most recent write or an error. Availability as every request receives a response, but with no guarantee that it contains the most recent write. Partition tolerance as a system continuing to operate in the face of messages being dropped by the network. So in other words, a network partition, or in the presence of a network partition, one has to choose between consistency and availability. Humans, on the other hand, are an entirely different beast, mostly able to operate independently due to superior partition tolerance, because we're independent free thinkers, but we tend to suffer a lot more from the consistency and availability. So humans are generally only consistent when executing the same task, which is generally a rarity outside of day-to-day work. It's introduced a slight variance, and the outcome can be wildly different. Humans are generally available, but only when waiting for work, and even then not 100% of the time, as you spend some time in the ideation phase, or, to be honest, watching cat videos and surfing Reddit. And their availability is severely hampered when fielding a large volume of work, as context switching for humans is a lot more expensive than for computers. Where humans can easily excel, though, is obviously partition tolerance due to their free-thinking nature, although it can come at a cost of consistency. As when procedures meant to protect process cannot be followed, faults can easily be injected, like doing a YOLO deploy on a Friday evening without your code going through job process, which I'm sure a lot of us have done more than once, or vimming a file in production because shit, like you need to. So in other words, humans are about as reliable as UDP. That is to say, mostly. So think of your organization as a distributed monolith and microservice architecture all rolled into one that needs delicate orchestration to ensure at least a passable level of communication and rate of work. The monoliths tend to be the old guard of your organization, the ones that hold the knowledge of every dark corner of your infrastructure and code base, know the little idiosyncrasies. And the microservices tend to be your newly formed teams and squads that hopefully have razor-sharp focus and tight feedback loops. But you need to break processes out so that you have to have well-defined methods of communication as well as response times required from them. So things like email and instant messengers are great, but they're asynchronous and people tend to not respond. I know I'm horrendously guilty of opening an email, reading it, and replying about 2 weeks later. But you can't always go tapping on somebody's shoulder because, again, context switching is expensive for humans. You also need to know when to break the circuit and isolate work so that it can finally get done. If it takes weeks or months to get some minor feature complete because it touches many parts of the system, considering an ad hoc team derived of members from responsible teams, throw them in a room together and get shit done instead of waiting for people to coordinate through like long project pipelines. And then to limit the amount of work which comes pouring in via some gatekeepers, because no one wants to run flat out 24/7, because that tends to lead to burnout and stress and anxiety, and much like I'm feeling right now. And you'll see some minor, more than just minor failures happening. So for consistency, we need reproducibility. And reproducibility is hard. Like, one only needs to take a look at the current projects in progress on reproduciblebuilds.org for the various flavors of Linux and BSDs, and what a mammoth task it is to make sure that things are reproducible. So we look towards configuration and infrastructure as code as a first target towards consistency. If we can run the same configuration tasks over and over, day in, day out, and never have a variance, we've succeeded in the first step of consistency. We need playbooks or runbooks for handling outages and diagnosing faults, because without such material, someone new to the organization or engineering in general will not know how to find a consistent answer when trying to diagnose problems. Automated remediation systems take this a step further, such as technologies like Stackstorm, and you can take your playbooks that are just sitting in a text document somewhere and actually put that in place so that you don't have to get paged all the time. Your documentation needs to be accurate and up to date, and you shouldn't have conflicting documentation systems. There should be a single source of truth. You should ensure that everything along all the steps is properly documented from your code itself to service boundaries and production documentation that lists caveats, running issues, as well as change logs, so that if you're not on call, someone gets paged, there's a new fault in the system, they only need to look so far in order to get, well, to drill into the problems at hand. And this obviously includes greater architectural diagrams, so that you can have oversight of all the moving pieces, the dependencies and boundaries, so you don't have to worry about digging into things that are irrelevant for the task at hand. So availability is probably the easiest to grok, but the hardest to practice effectively. The first item is to ensure no resources are blocked for longer than they truly should be, and bottlenecks are swiftly taken care of to ensure a proper flow. Controlling work in progress is incredibly important for availability. The wait time is defined as the percent of time divided by your percent of time busy divided by your percent of time idle. So if a resource is busy 50% of the time and it's 50% idle, the wait time is 50% divided by 50%, which is 1 unit of time. So if that's 1 hour, we can call it that. On the other hand, if the resource is 90% busy, then the wait time is 90% divided by 10%, or 9 hours. So if our task was sitting in a queue 9 times longer than it's than if you're 50% idle, and if your task is going through 7 steps, and all of those steps are at the same level of busy, that change that you think is only going to take half an hour is actually going to take you about 63 hours just to get to the front of the queue. So there's obviously a lot of story tracking software out there. Encourage you to go and experiment with them. Some of my favorites is Clubhouse. Jira's okay. It works for what it works for. Or GitHub issues, but GitHub issues have a problem that you can't cross-tag issues from one repo to another, which is slightly annoying. And then, yeah, at the end of the day, unless it's a P1 severity issue, like no task should jump straight to the front of the queue. You shouldn't have the CEO walking in the door, banging it down and saying, this needs to get done now. It should go through proper process, otherwise you end up screwing the workflow system. So, with partition tolerance being seemingly easy for humans, as we have generally a far greater queue depth than machines to work through, we still need some help. So, if you had to sit down and think of a theoretical scenario that half your organization was on a plane for 12 hours and you've got a critical outage, would the other half be able to function and resolve the issues at hand? I mean, hopefully so. It's just an outage. It's not that bad. But what happens if you were to lose half your staff? So people decide to go and quit. You know, and it's a mix of all seniority levels and experience. Would you then still be able to operate? Is there knowledge trapped in these people that haven't been communicated out and socialized with the rest of the organization? You know, was stuff done back of the napkin, and now you have no idea what's going on. So in order to resolve some of these potential failure points, the direction or roadmap needs to be well laid out and clearly mandated. So I'm not talking waterfall and having thousands of pages of documentation covering the next 3 years of projects you're never actually going to do because it's going to be crap by the time you get there, but rather have the next 3 to 6 months clearly defined and the next 12, 18, 24, and 36-month phases covered in at least a high level of detail so that people know sort of where the direction is going and know what to do next. So if people are away on holiday for 6 months or sabbatical, they don't have to worry about what are we going to be doing. So some tactics to employ. This is definitely not an exhaustive list, but it's just a starting point I kind of came up with. And obviously this is like my opinion. To how to better transition to that state. So, radical candor. I don't know if anybody's read the book by Kim Scott. The byline is actually how to be a kick-ass boss without losing your humanity, although the boss portion can easily be substituted out with team player. It has a very simple ideas that in order to be a good boss, you need to care personally and challenge directly. And while there's good tenets in the book, I took away some other points to that. So the first being openness, which to me is being receptive of new ideas and accommodating opinions. So if people can't make their suggestions heard, they're going to stop suggesting. And what that leads to is a failure to innovate, and you end up with a sucky culture. Honesty, so the ability to be honest without fear, like that also stimulates a healthy culture. You know, you tend to have no backstabbing, infighting, or issues get resolved fairly quickly. You don't end up in mediation meetings with HR because of some nasty words spoken. Authenticity, being your genuine self, that helps set you more at ease. If you're not telling white lies about certain things to certain people, you don't have to keep track of that crap, and you can just get on with life and you know, divert your energies elsewhere. So it's not draining. And it's much better for me at least. Then being vulnerable. So this is being able to accept somebody's honesty to you. If somebody comes to me and say, hey, they don't like what I did on Friday at 5 p.m. because I went and rolled out production changes without going through a process, I should be able to be vulnerable and accept that feedback and not, you know, lash out and act like a petulant child. And then, obviously, a culture of feedback. So having tight feedback loops is one of the best ways to ensure items don't slip through the cracks. Without feedback, you tend to be chasing other people's tails, trying to get information out of them, which leads to context switching and juggling things, and you end up dropping balls constantly. I know I'm guilty of this sometimes where I'm so stuck in my work that I forget to give status updates. And actually, in 18 minutes, I'm supposed to submit a stand-up report. So failing fast is one of my favorites because I'm historically bad at knowing when to kill projects, but I delight in the first point here, which is willingness to experiment. So willingness to experiment should not be seen as an affront to existing systems or processes. It's actually a great thing to have, and you have multiple tiers of rewards for you and your team and your organization. Firstly, you get to do something new in potentially shiny new language or framework, which I always like doing. And secondly, you could actually yield something of value, perhaps not to the organization at this point in time, but what you experimented on might help someone else down the line. With that being said, you've got to know when to kill shit. You know, if after 3 months of experimentation, you and 2 colleagues still haven't managed to write Hello World in OCaml, you're probably not going to get around to writing that fancy distributed lockless queue you're planning on building. So don't worry about culling things. They don't necessarily represent failure, as long as you take some learnings away from the experience, which is the most important thing. So even if that learning is rather write it in a language that you know already and then iterate on that, you know, that's a valuable lesson to pull out of it. So perhaps start small with some dedicated hackathon days before going and doing it. Everyone has 20% time to do whatever they want. Just put a deliverable on it, whether it be a small presentation at the end with learnings and outcomes, perhaps full-on demos if you do something really cool, but you'll get the creative juices flowing and people become more willing to experiment in your organization. So blameless post-mortems. Too often we work in organizations where people like to wag the proverbial finger when it comes to incidents and outages. But we need to understand that blameful culture tends towards cover your ass engineering, and your engineers end up being silent about the actions, situations, and observances of the incidents at hand. So be deliberate about your postmortems. They should be considered critical enough that you put a halt on other work to hold them, and preferably do this within 48 hours of an incident so that's still fresh in your mind. Quite often I've experienced where trying to do postmortems and we end up only getting to it 3 weeks later and no one can remember what the hell went on because we probably didn't do enough documentation during the incident anyway. So develop the fundamentals of postmortems. If you've got the mechanics memorized, in other words, things like the meeting format, the same data being prepared, the same output deliverables, you can use that cognitive energy you saved to pay attention to other softer, more delicate human interactions during your post-mortem that can help refine your process. And then there should be actionable outcomes from your post-mortem. If at the end of the meeting the conclusion is, let's try not hit that button again, that's not terribly actionable. So having a tangible outcome, even if it's like putting an alarm bell in and a pause when you try an RM/RF route in production, you know, at least that's better than nothing. So silos are great for storing grain, terrible for storing knowledge, because they're very isolated. Knowledge is meant to be shared both inside and outside your team. Hoarding institutional knowledge is one way to ensure you become a bottleneck in future. When you're the only one in the organization that knows something specific about the stack or some idiosyncrasy, you become the sole maintainer of that, and that's burdensome. So document and express that knowledge to other members of your organization so that they can maintain continuity while you sip Mai Tais on the beach every once in a while and you get a break. So unless there's a justifiable reason, open should always be the default policy. Everyone should be able to see all the repositories for an organization. There might be things that should be kept hidden. So for example, credentials for the payroll system, that should only be shared with people in positions of fiduciary responsibility because, you know, who doesn't want to go and add an extra zero to their paycheck at the end of the month? So to that end, we need to communicate effectively both inside and outside of the organization. Lines of communication should be clear and well defined. So is your door always open, if you have a door? Or do you want someone to call ahead and first check your availability? Do you have different rules depending on the time of day when it comes to communicating? You know, if somebody sends you an email at 6 p.m., are you expected to reply by 7 p.m. or will you take care of it the next day? And with that being said, the communication channel should be succinct and not needlessly cluttered with extraneous information. So if you're having a meeting over something like Slack and someone keeps dropping pug pictures into the meeting channel, that's needlessly distracting. Like, the pugs can wait for 30 more minutes. So, yeah, and you want meetings to be over. So if you set it for 1 hour, it's 1 hour. I got into the habit many years ago of running meetings that I would literally close my laptop and walk out the door once the time box is over, because I had execs that would just ramble and ramble and ramble and never get to the point, and it's just needlessly infuriating. And after 2 months of just like, well, I was up, laptop's down, I'm out, they changed their behavior and actually got to the point within that hour. So it helps a lot. So I strongly believe in a culture of continuous learning, whether it's inside or outside the scope of your work. I take random courses sort of every 6 months or so on random things. I last did magic in the Middle Ages and recently did something on Chinese tea ceremonies. So obviously that's cool to do, but the company's not going to go and pay you to go and take a 30-minute break making tea in the kitchen every time. But you should identify places where you need training. So if you're spending, say, 4 hours of your day in Excel, but you're probably only productive for about 30 minutes because you don't know Excel, well, maybe that's a place that you need training. So go out, seek it, and rectify that situation. Or if you're building dashboards for clients, internal or external, and you don't know what the impact difference is between various graphs and charts, then that's a good thing to go and study. It's a little bit of UI, UX, and marketing information. So I like 10% of my time to be focused on learning. I mean, that's 1 day every fortnight, which isn't really a lot, especially when you consider that on average people are only productive 5 hours a day. You've got a lot of time that you could be learning other things. And it helps build up your skill set and learn interesting and new things that could help you solve problems creatively in future. So mentorship, this is obviously a difficult point because it's hard to find mentors, but everyone should have one. And you should change them as well, because the mentor you have today might not be the mentor you need tomorrow. They might not have advice that's pertinent to you anymore, or your domain has changed so much that you need to seek alternative advice. The various 12-step programs, I don't know if anybody knows, like Narcotics Anonymous and Alcoholics Anonymous, but they do this pretty well. It's called sponsorship there, because you're sponsoring somebody's sobriety, but you're there to help offer them helpful, salient advice to get them through their life, and very much so, that's what a mentor is in business and technology. And obviously just remember that not everyone wants to be a mentor, so you shouldn't go and try and force people to mentor others. It's something that's hard for a lot of people. So feel free to go seek it from external people if you can't find anybody in your company to talk to. And yeah. Cool. So cross-team pollination. It's a great way to ensure there's a diverse set of knowledge running throughout the organization, with a bus factor high enough that you can throw 3/4 of your organization under the bus before you start seeing any cracks. Through the engineering space, it's quite easy to obviously just move your laptop and go sit at somebody else's desk for a couple of hours or a day or two. It becomes harder when you want to try and move to a team for 2 or 3 sprint cycles and you're ignoring your work though. So make it a value for the organization, allow for it. A few organizations I know have a 6-week transfer that you can do internally. You can move complete teams, jam and a bunch of other stuff, and they're completely okay with it because they've actually got in place enough knowledge and cross-sharing that it's not a problem. And don't be afraid to go to people that you might not think can teach you something. You know, you might say, hey, that person writes Java, but I write Go, what can they teach me? You'd be surprised. Like, don't go and focus on thing X compared to your thing Y. Apples and oranges, and yeah, everyone can teach you something, and everyone can teach something. Yeah, messed that up. Then explicit knowledge sharing. So this is things like brown bag sessions or lunch and learns. It's a great start to ensuring knowledge is socialized within an organization, and it also serves a dual purpose. So it allows people to practice in the art of presentation, preparation, and conveying a message, as well as creating greater awareness of various processes and technology. But you must remember that not everyone's going to be able to attend all these sessions. So where possible, record them, or at least a minimum make your presentation available as well as your notes for other people to peruse at a later stage. And although sessions should generally be focused on topics that hold business merit, or something that's coming in the pipeline in the future, people should be allowed that space to share knowledge about subjects outside of scope of regular work. So this can also inspire change. Perhaps you've gone and built a set of garden monitoring IoT devices, recording soil moisture and ambient temperature to enable water savings. And that's a worthwhile cause, and maybe it'll inspire people in your company to do something about their home gardening situation. So it doesn't have to be about work all the time. So I've seen 5 levels of leadership in organization. So the first level I found is the highly capable individual. This is the type of person that makes productive contributions through talent, knowledge, skills, and good work habits. They tend to be the majority of your organization. And while they're great to have, you should always try and work to get them towards the second level, which is the contributing team member. So they help contribute to the achievement of group objectives, work effectively with others. They're aware of others and the requirements of working in a team, and they're also less likely to silo and turtle, and will hopefully at some point assist in mentoring process to lift individuals out of their state to team members. And we have the competent manager, and I'm sure you're a lot of rolling your eyes at the thought of competent managers. They are hard to find, but hopefully you do know some of them. They manage to organize people and resources towards effective and efficient pursuit of objectives. They will hopefully definitely ensure that teams are not blocked and do not get unnecessarily bothered by things that halt them in achieving their objectives. They're very much nice to have when you do find them. Fourth level is sort of the effective leader. This would be maybe someone like your VP or dev managers. They tend to be a catalyst for the vision of the group, stimulates high performance standards, and they ensure that the vision is clear and concise and properly socialized with all stakeholders. And the final level is the executive, which hopefully you've had a chance of working with some great executives over time. I know I have. And they strive to build greatness through personal humility and professional will. They're like the thought leaders of the organization, and occasionally they might be gruff and overbearing, and sometimes they just come barking into your office and demanding things that they shouldn't. They do help drive the organization to higher levels of being open to new ideas and concepts without the fear of being the smartest person in the room. I mean, it takes a good person to sit down and realize that, hey, I'm not the smartest person here, I don't know all the answers, and I'm willing to accept somebody else's input. And all these traits help to stimulate an organization that should be consistent, available, and tolerant of change. So, rounding up close to the end, there's 4 steps I've found that help towards inventiveness and creativity. The first is, don't assume that things have been done in the best way. Quite often, a system is built using antiquated methods, and there might be new novel solutions to the problem at hand. That is not to say, like, always chase the shiniest ball in the room, but don't be scared of looking into new developments that might help you solve the issues at hand. When a task or change effort emerges, encourage creative ways of getting it done. Learn to think outside the box, as there might be a trivial solution that can be creatively applied to the problem or change effort at hand. Experiment with different ways of organizing work and find alternative methods of grouping and linking people. Having teams siloed with no cross-pollination tends to create an echo chamber of ideas, which hampers creativity and generally forces you into a change-adverse mindset where you struggle to get out of the rut of building the exact same mistakes over and over again. Fresh eyes and brains can encourage inventiveness and creative problem solving. Someone else might come from a domain where you're trying to solve, or what you're trying to solve is already a solved problem with existing tools, frameworks, or libraries, but you might not have any knowledge of these domains, so you end up building in isolation what could have been done in 3 minutes with some sed and awk. And then, when working to understand your current environment, ask yourself what other options are possible. Like, that is to say, look at the larger ecosystem as well as the problem in detail and make a real determination on if there's a real need for what you're planning on doing. You might have misunderstood the requirements, and the real options are staring you in the face. Ooh. So, some final thoughts. Like, DevOps promotes a culture of rapid experimentation, which allows us to adjust frameworks over time and find the right fit. No one person has all the answers, and we need to take it upon ourselves to break the mold, successfully iterate to become we can be. And leave you with a quote I quite like from Bruce Lee, which has stuck with me for a great many years of when I used to do Wing Chun. Be like water, making its way through the cracks. Do not be assertive, but adjust to the object, and you shall find a way around or through it. If nothing within you stays rigid, outward things will disclose themselves. Empty your mind, be formless, shapeless like water. If you put water into a cup, it becomes a cup. You put water into a bottle, and it becomes a bottle. You put it in a teapot, it becomes a teapot. Now, water can flow or it can crash. Be water, my friend. Which I've always taken to mean that there's always a way to solve the problem or situation at hand, provided you're not stubborn and you're willing to adjust and learn, and you can see the light. For me, that's been particularly the DevOps movement, because it's ever-changing. It's shaped to fit the problem domain at hand, and it's nice because the same day is never really repeated twice. And yeah, thanks for your time.
One, two. For the sake of time, can we have 2 questions? No more than 2. No questions?
Nice.
1 question.
Hey, Christian. You mentioned that you switched to management 6 months ago. So what's been the toughest challenge, or like the mind shift you've had to make?
Getting out of blindly focusing on work and getting things done, and being able to step back and look at the greater picture, as well as communicating with people. It's normally quite easy to just go, cool, I've got some tasks, I'm going to bang them out. Now you actually need to work on building those tasks and then communicating with other people in the organization. Quite often I spend my Wednesdays till about 11 p.m. in meetings with our companies across the globe, which is horrible, but yeah, it's what you got to do, and it sort of breeds good conversations by Yeah. Hope that kind of answers it.
Another question? Did I see a hand? No hands. Great. Thank you very much. I'd like to encourage you to chat to Chris over the next 2 days.
I'm the Chief Email Officer at Obsidian, because I feel that that's what I do most of the time. For those of you who might not know, we've been around 23 years, focusing mostly around open source technologies. And trust me, our world has changed since we started getting Linux on a stack of stiffies. For those of you, it's things that we used to put in computers. You guys look very young. That's where we started, and our world has changed a lot. Nowadays, our big focus is helping customers take their teams to make sure that the right code gets to the right compute and the right data. That ultimately for us is all that it's about. So whether you've got COBOL and mainframe, or whether you have a self-driving car, it's the same problem. You've got to get code to the right compute and the right data. And careful for latency, it literally could kill you if you get it wrong. One of the things I thought I'd share with you guys, I was lucky enough to spend a couple of days with the Microsoft exec team in Redmond earlier this year. And I met a guy there called James Whittaker. His title is Distinguished Engineer at Microsoft. Maybe one day when I'm big, I'll have a title like that as well. And he shared Microsoft and just how they've changed. And I don't know, for those of you who've been around for a while, hopefully you'll agree that Microsoft as an organization has fundamentally changed. From things that, Linux is a cancer to now Microsoft loves Linux. They've realized that collaboration will get them a lot further than being in a silo. And he shared a little bit, they had a look at IT, and they identified a few key areas over the last couple of decades. We had mainframe. After mainframe, we had client server. Then we had the World Wide Web. And then we had mobile. And they looked at that and they said each one of them was roughly about a decade. And then a big disruption happened. And the interesting thing that they noticed, within each one of those decades, you could start seeing the next disruptive technology. But people didn't always realize what that would be. And if you think about those, they were quite disruptive. And it was interesting, they admit that they missed mobile completely. And they asked themselves, so what is the next thing? If we can learn from the past, those bits and pieces are already there. It's deciding which of those will be the most disruptive in the next phase of IT. And they've identified things like the Internet of Things. Everything is going to be connected. AI, let's face it, the computers learn quicker than we do. And augmented reality. And he used the example, there's probably not a person in the room that doesn't have one of these. And he said, why is it this size? And it's probably the battery and the screen. So imagine a world where screens are nowhere, everywhere. That's in your glasses, it's projected on a wall. How does it change our world as developers and how we help our customers? And this is the thing that he challenged everybody in the room, is to say, how do we start thinking about a world where everything is connected, we have machines answering questions that we haven't even thought of, and access to that information all the time. And I think DevOps is probably the movement that will hopefully get all of us get to the point where we can innovate fast enough to survive in a world like that. So I encourage you guys to come and visit our stall, find out a little bit more about some of the technologies that we do. So whether it's our main sponsor from our side for this event is Atlassian, so come and hear what they do. We have Grant Finnemore doing a talk later this afternoon just showing you guys how the stack can help in an SDLC and ITSM world. But also come and chat to us about containers, things like Hadoop, a whole range of technologies that we do that we can help you guys. As a parting thought, just keep on learning. We can never stop, because if we're not learning something new today, we're probably falling behind. We have seen massive innovation in IT and change. It has never been this fast. And for me, the scariest thought is it'll never be this slow. So good luck, enjoy the rest of the conference, and thanks for having us here. Cheers.
In the coming 30 minutes, I'll be speaking about how we deployed Kubernetes in production and the challenges we faced and the techniques we used to overcome those. I'm Rahul Mahale, a FOSS enthusiast, currently working as a DevOps engineer at Big Binary and currently shipping containers to production. I firmly believe in principle infrastructure as in code, and we at Big Binary are Kubernetes service provider partner, and that is my Twitter handle. Apart from that, I love playing and watching cricket, and AB de Villiers is one of my favorite players. Okay, so yeah, the containers, Docker, Kubernetes are the buzzwords or serverless. So I'll be telling most probably on how to directly deploy applications on production using Kubernetes. So we'll see how to cluster provisioning considerations for production using Kubernetes, high-level requirements for any orchestration tool, and deploying applications on Kubernetes. So yeah, Docker is cool. Docker pull is really easy, and running a base image or running anything into Docker is really easy. But running a Docker in production is really not that easy. It takes a lot of efforts to run your production-ready app on any orchestration tool, maybe Docker, Docker Swarm, Kubernetes, Apache, Mesos Marathon, or any other container engine. So we'll see how Kubernetes does that. So prerequisite for this talk. So I assume you all know about a Docker and Dockerization of application. Okay, first thing, how many of you use actually Kubernetes or any other orchestration, container orchestration tool in production? Oh, cool, in production. And how many of you use Docker? Okay, that's good, almost 30–40%. So yeah, that's the right crowd. So I assume you know Dockerization of application or containerization of app. If you don't know, don't worry. Watch a latest talk from DockerCon Europe where they have introduced Docker application converter. Just run a single command and your complete server, your existing traditional server will be Dockerized. So that is one thing was latest release from Docker Foundation or a Docker community. Then also I assume that you know about various tools, orchestration tools of Docker like Docker Swarm, maybe Google Container Engine, ECS, some of the vendor tools, or Apache Mesos, or anything. This talk is going to be focused mostly on Kubernetes. So some of the highlights. A server might be on a bare metal or on public cloud which has container runtime installed, maybe a Docker or any other equivalent variant. Then a storage for that container might be your volumes. If you are using a host volume, if you are mounting it, your storage should be available for that host. And then obviously a network to communicate with your host and over the cluster. Then some of the features for Docker orchestration tool we want while running containers in production is handling user authentication and authorization. If we are deploying multiple applications on any of the orchestration tools, we need to isolate and give a right access to users. Then how to expose services. With containerization, we don't actually have assigned public IPs to your services or load balancers. Yes, we do have load balancers and there is a service type of load balancer, but one orchestration tool should be intelligent enough to bind your application URL with the services and expose them publicly or internally. Then how to access legacy backends. The stateful sets and persistent volume storage also comes, is the important part of any orchestration tool. And resource management and isolation of different users and teams, and handling highly availability, backup and restore, meaning that if you are running your application on container orchestration platform, you have to have it highly available and fault tolerant. Okay, first thing, when we Dockerize our application, it has to be an image, either it is your application image or like whatever you have to Dockerize, it has to be image so that you can pull and run. So where to get the base image? You should follow the best practices to write your Docker file and build your Docker images. That has to be used in your application deployment on production. So how to handle multi-arc builds? There are some image distributions which are specifically for Docker, like Alpine image, CoreOS image. You can get out from your Debian or Red Hat based architecture and use them and tune your performance for image building. Then how to scan the images for any existing vulnerabilities. When you are building an image, you as of now from Docker Hub or from Qued, they by default provide a vulnerability scanner. They will tell you that this image or this package has the vulnerability and you need to fix them. So keeping that in our deployment pipeline is important thing. And the important thing, where to host the images, either on public registry or if it is a private registry, we have to host it on like self-hosted or a public hosted. So that's up to the user which one to use. And configuration management, like how to store the secrets, the sensitive information, encrypt them, and how to provide them to containers or pods when they actually need it for application usage. Logging is important part of any of the application, and we should consider implementing a better logging management for running containers when we are actually running it in production. And yeah, monitoring wherever you go, either you are on your traditional server architecture or on containers, one needs monitoring. So we need a detailed monitoring so that we can take actually a call about anything like scaling, auto scaling, and all that stuff. So these are some of the features one needs from container orchestration tool, and Kubernetes is one of them, which is rich in having all these features. So as I mentioned, every orchestration tool is opinionated when it comes to describing a containerized application. So it's up to user if you have to use Kubernetes, if you have to use Docker Swarm, or if you have to use Mesos, ACS, or ECS. So this talk is mainly focused on Kubernetes. Okay, so before going further, I would like to brief you about Kubernetes architecture and what are the important components are present in Kubernetes. So Kubernetes consists of two parts: masters nodes and kubelet nodes. So master are responsible for maintaining a Kubernetes cluster and the health of Kubernetes cluster. On master, we first of all, it might be on any public cloud provider, bare metal, the VMs, anywhere. And when we provision a master, it has etcd. etcd is a persistent storage database, a key value store database from CoreOS, which has health of complete Kubernetes cluster. So all the configuration related to Kubernetes are in etcd database. Then there is control manager. Control manager is responsible for maintaining a desired state of configuration. How much pods to spin up, what is the deployment state, what is the replication controller for the certain kind of manifest. For this all activities, control manager is responsible, and it takes care of that. Control manager runs on master node. Then there is kube scheduler, which schedules the pods, meaning that if new pod is spun up, kube scheduler will take care of scheduling it on a certain node which is healthy and can API server using which you can interact with Kubernetes resources. kubectl is one of the command line tool using which you can interact with Kubernetes and you can create and delete resources using kubectl. Also you can use REST API and other tools. You can directly connect to REST API and like create and delete resources from Kubernetes. So this is all about master node. On the nodes, on the kubelet nodes, where actually your application runs. So there has to be any container runtime environment or Docker. Docker is one of the famous, but with Kubernetes 1.8 version, we support multiple container runtime environments, might be a Rocket or some CRIO. So Docker is one of them. Then there is a kubelet. Kubelet is a process which keeps running all the containers or pods on the node, and it is responsible for sending a heartbeat message to master that this node is healthy. So kubelet is one of the important component of the Kubernetes node. And kubeproxy is also used to say that we can say that it is a service discovery mechanism of Kubernetes, and it actually routes the traffic based on IPs to the containers and pods. So the master node consists of etcd, API server, scheduler, control, and kubelets, where our application runs consist of kubelet, container runtime environment, and kubeproxy. So before deploying application, we have to know some of the terminologies of Kubernetes, and I won't describe them in detail, but just to say about pods, which are like a low-level abstraction layer of Kubernetes, and every container in Kubernetes is termed as pod. A pod can contain more than one container, and all the containers in same pod are in same namespace and are scheduled on single host. Then deployments. Those are supervisor to the pods, and they maintain a state of all the containers assigned, meaning that if we have scheduled to run 2 replicas of a container, the deployment is responsible to make them up. If one of the container goes down, deployment controller will take care of spinning it up and make all the 2 replicas up and running. Services are the abstraction layer of Kubernetes, using which we can actually communicate through the applications. Services can be of 2 or 3 types. One is cluster IP services, using which we can communicate within a cluster, the load balancer service, and via external IP service, using which we can access our application over the public or over the internet. Config maps are a way to decouple your configuration files from actually Docker image. So if you have to change your any configuration file, maybe a database.yaml from your application, you don't have to go through a complete deployment configuration. Just use it as a configuration map, change the config map, and just trigger the pod. The change will be automatically deployed to your application without building an image and going through complete deployment lifecycle. Then secrets. So we have to have a way to encrypt our secrets and sensitive information. So Kubernetes has Kubernetes secrets. Till Kubernetes version 1.7, they don't provided actual encrypted secrets. They were just base64. But with Kubernetes 1.8 version, now we have encrypted secrets, and we can store our data in secrets and all the sensitive information, which can be retrieved over deployment for pod or application usage. Then jobs. For a periodic tasks or for custom tasks, we need jobs. Till date it was easy. We could just log into our application server, SSH or login, run few commands, and that's it. But as containers or pods are immutable, we don't actually have to all the time log into our containers. So instead use jobs. Jobs will execute the task, they'll complete, and they'll terminate the pod. So we have to know about Kubernetes jobs as well. Scheduled jobs are nothing but they are cron jobs scheduled to run on specific time. And there is important thing, horizontal pod autoscaler. HPA autoscales automatically when there is need of autoscaling. Currently it supports CPU based autoscaling, meaning that if you have specified 80% of CPU usage to scale up, Kubernetes will automatically add more replicas and maintain a healthy state of application. So Kubernetes supports horizontal pod autoscaling. So 2 grounds when we have to deploy application on container platform like Kubernetes. First is provisioning production ready Kubernetes cluster, which can be managed by your cluster operator who has to come up with the production ready Kubernetes cluster. And second is deploying application on the Kubernetes cluster. So if you want to go for any vendor Kubernetes cluster, there are multiple cloud providers who offer it. GK is one of them who offers Kubernetes based cluster. But if you are provisioning of your own, because as per the survey, more than 60% of people run their own Kubernetes cluster on a public cloud like AWS or on bare metal. So it's important to know like what all things has to be taken care when you deploy your Kubernetes cluster. So when we have to deploy our Kubernetes cluster, first it must be highly available, meaning that we don't have to have any downtime in any case. We should be having multi-master Kubernetes cluster. Then secure, must be behind VPN and secure networking, and auto scalable, meaning that we don't have to over provision. Whenever we need the more resources, our cluster must automatically add the nodes, and whenever not needed, it should scale down. So where to do it? So provision highly available cluster using KEOPS. We mostly run all the resources on AWS. So KEOPS is one of the tool to provision Kubernetes cluster on AWS. It also supports provisioning of cluster on Google Cloud, but it's in alpha. Then we use private networking using Calico. Calico is one of the networking type which Kubernetes offers, there is also Viv, and there is also Flannel. So we use Calico and use cluster autoscaler Kubernetes add-on from community itself. We have to specify our threshold minimum of 5 hosts, meaning that it will spin up cluster of 5 nodes with minimum 5 nodes and maximum of 20 nodes. So if we are specifying 20 nodes, whenever needed, it will add more and more nodes until the 20 nodes are full of capacity. So there is a cluster autoscaler add-on for AWS from community itself. If you want to deploy your cluster on other cloud providers or on bare metal, there are tools like KubeADM, KubeSpray, and also there are some vendor tools like Tectonic from CoreOS and others. So with respect to storage, Kubernetes has persistent volumes, and with AWS it works great as it uses AWS EBS, Elastic Block Storage, and it can be used in your application. Also you can use NFS storage if you want to scale up and down your persistent volume applications, and host path is one of the way for volatile persistent storage, meaning that when your pod is restarted, the host path type volume, the data will not be stored. Then there are certain options like Gluster file system, Ceph, OpenEBS, and Rook, which are like third-party options. But if you are looking for persistent storage, you can also check them. So the important part, as I said already, that containers are mostly for stateless applications, and people don't rely when you want to store your persistent storage data on containers. So first thing is, if you want to run your application on production, where to host services like database. So it is possible, it is really possible with Kubernetes version 1.7 and 1.8 using stateful sets. So one should go and try out stateful sets, and if comfortable, should go for hosting database or backend services on Kubernetes using stateful sets and compend persistent volume. We being on AWS, we used RDS and it worked great, because RDS is really a great service from AWS, which takes pain of handling database services. So when we launch an application, we have to have our database instance pre-created, and we need automation for that. So yeah, I'll tell you further like how we automated it. The networking is an important part of Kubernetes. KubeNet is a default networking type provided by Kubernetes, and Calico, Flannel, Vivworks are others you can choose, and you just have to check like which automation tool suits perfect for your networking type. So important thing, first thing is image building. So though I won't be going into complete CI/CD pipeline of deployment, the image building is the one I need to like just explain out. So base images, if you are using from public registry, like if your application is PHP, you'll just use public image of PHP with the proper version number, and you could just add your abstraction over that for your application and deploy it. That the image building can also be self-hosted. You can build your images using Jenkins. As with Docker Cloud and other things, they don't provide actually a parallel build image building, meaning that if you are running your image building on same repository, it will queue your image, and that can slow your deployment life cycle. So we switched to Jenkins. We use we build image on Jenkins and host it on self-hosted Docker Hub registry. So the generic best practices to follow when you are building images: one layer for base image, one for user configuration, and one for application. Your Docker file must be as small as possible to minimize the Docker image building time. Leverage user directive, and if possible avoid using a root user directly. Create an application user and perform all your application stuffs using that. Ensure regular scanning of images. As I mentioned earlier, Docker Hub already provides a scanning of vulnerabilities. If you aren't using Docker Hub, you should always scan your Docker images and check what are all the vulnerable packages and run CVE patches for them. And yeah, use environment variables wherever needed. Don't just hardcode all your information which is sensitive in Docker files or in your deployment pipeline. So resource management, one of the important part when you are deploying containers, one namespace per user group. So there is a concept called namespaces in Kubernetes, using which you can isolate your resources. So if you are running everything in one namespace, let's say if you are creating app 1 and you try to create the app with same name in same namespace, it won't create. Instead, create a separate namespace for separate client or separate app, and it will allow you. So one namespace per user or per group is recommendable to keep things in more good way. And also separate namespaces for your environments, maybe development, testing, staging, or build. Then specify resource quota. So let's say we have deployed one of our container in production and it is having memory leaks. So it will go and consume more and more memory, and our autoscaler will keep adding more and more instances to our cluster, which is not an ideal case. So instead, space a memory or a CPU quota, meaning that for this container, the highest limit is 4 core of CPU and 8 GB of memory, or 2 core of CPU and 4 gigs of memory. Whenever the quota is reached, either the container will autoscale if the HPA is added, or it will restart. So specify resource quota in your deployment manifest of Kubernetes. Then authentication and authorization. If you are running multiple applications on single Kubernetes cluster, it is very important to specify a role-based authentication. You have two ways to do that with Kubernetes. One is attribute-based access control, and other is role-based access control. So you can restrict access to the particular Kubernetes or kubectl user for the particular namespace and attributes, meaning that the application user, the application one user cannot access the data of application 2 users. So you have to implement all these practices using RBAC. Also, you can do it using webhooks, custom modules, or some third-party resources for Kubernetes. Important thing, when we want to deploy any application, that must be zero downtime. So for cluster upgrades, in terms of cluster upgrades, COPS supports out of the box rolling updates for clusters deployed on AWS, and we should ideally go through it and use it, COPS rolling update. But for deployments, if you want to handle application which runs on Kubernetes and should be deployed in zero downtime, there is something called health check, readiness and liveness pros, and container lifecycle hooks. When you deploy your application on Kubernetes, your service checks or just sends an health check to the pod. If you're on port 80, your health check is up, then only it will route your traffic. In that case, if you want to have zero downtime deployment, you have to deploy your application with at least more than 2 replicas, so that when you deploy, your one pod or your one container is always serving a traffic, while other is rebooting, or other is doing a rolling deployment. So for that, there is a readiness and liveness probe. Readiness probe is something that ensures that your pod is actually ready to serve the traffic. Unless and until the success threshold is okay for readiness probe, Kubernetes service will not route traffic to the that pod. And there are some container lifecycle hooks using which you can track your pod lifecycle and make sure that your pod is up and running. Important thing, after services, you should check ingress controller, though you have load balancers, and Kubernetes supports deployment of application using load balancers. Using ingress has its own advantages. First of all, it uses L7 load balancing, then SSL termination on ingress itself. Also, you can, using ingress, you can specify path-based tools, so that you can specify /abc or /xyz request should directly be routed to this service, and multiple host names. This is all possible with single ingress, which uses Nginx. Then autoscaling of applications on Kubernetes. So as I already mentioned, horizontal pod autoscaler, but as of now only Kubernetes supports only CPU based autoscaling, meaning that you can't scale based on memory or request per seconds. So there is something called memory-based autoscaler. I think it's in pipeline and it's not stable in version 8.8. Instead, they have added custom matrix autoscaling. So for memory-based autoscaler, we wrote our own memory-based autoscaler, and it's really easy to write. Just watch out how much your memory is being used. If it is 80%, take a mean of your pods and add more pods, and similarly scale down. There is something interesting called custom matrix autoscaling. So apart from CPU and memory, we might want to scale sometime based on request per seconds or query per seconds or some request counts. So with version 1.7, we have that. We have to create our own third-party aggregation layer, meaning that we will create our own API version, and using that we can create custom matrix autoscaling, and that works out of the box with version 1.7. Then Kubernetes jobs, use it for custom and periodic scheduled tasks or unscheduled tasks. If you want to run cron jobs and you are running Kubernetes cluster 1.6, you have to restart your API server with this flag, and make sure that your restart policy is on failure, meaning that your pod will be restarted, the same pod will be restarted. If you don't put it and your job is failing, it will keep continuing spinning up new and new pods unless and until your pod is in running state. But your pod or your command is buggy, it won't happen, and Kubernetes has a limit. So Kubernetes can schedule only 100 pods per node, and in a cluster you can have only 5,000 nodes. So to prevent these scenarios, we have to take care of such flags. There are some known issues if you are running Kubernetes into production. The ticket number 42164 in upstream Kubernetes repository, your nodes might go into not ready state over and over again if they are like going over requests. To avoid such issues, first thing, if the issue occurs, just SSH into your node and restart your kubelet or Docker, but before that drain your node, meaning that just remove all the resources running at on that node. After applying drain to that node, Kubernetes will gracefully move your pods from that node. And important thing, to avoid these scenarios, request must be less than limits, meaning that if you have specified one core of CPU to a certain pod, you should not actually request directly one core right away. Instead, request 50 to 60%, 0.5 core of CPU, or same way the halfway of memory. This will not result in occurring this issue. Other main issue is if you are using persistent volume claims, those deployments or pods are not scalable, because the same volume, at least with AWS and some cloud providers, the same volume cannot be attached to multiple pods. So make sure if your application is scalable, you are not using persistent volume with this kind of. So some of the issues while upgrading your cluster, and if you are using COPS, it might break if you are using Calico networking. So this is known issue. So they have provided one fix, and there's the link for that. Also make sure if you are running your production cluster and performing some cluster upgrade, your COPS version is supported for the target Kubernetes version. So meaning that if you have to provision Kubernetes 1.7, you have to use COPS 1.7, which is officially supported version for Kubernetes. So important part, monitoring Kubernetes cluster and applications on you. Hipster and InfluxDB are the add-ons available from community itself, which gives you monitoring information in top style command using kubectl top nodes or kubectl top pods. But the important thing about monitoring is you can use Prometheus. Prometheus is itself a huge and awesome monitoring tool, and using that you can actually monitor entire cluster and your pod resources. There is a community dashboard available for Grafana, and use it. We can use Alert Manager, which can send us alert on Slack, Gmail, anything, or which can also be integrated with PagerDuty. So while deploying Prometheus, make sure your node exporter and Prometheus core has been configured with resources limit, because those two pods tend to consume a lot of resources and can eat up like 10 GB or 12 GB of resources. There are other tools for monitoring as well. You can check Datadog, Sysdig, ViewScope, and others. For logging, there is also an add-on called EFK, instead ELK. With Kubernetes, they use Cloud Native Fluentd, which is Elasticsearch Fluentd, and Kibana. And plus that, we use Logtrail, a paper trail style tail, or just if you want to see your all logs in tail format, use Logtrail plugin, which will display all your logs in tail format on browser. So important thing is automation. You can, like if you want to deploy your application on Kubernetes, you have to come up with your own artifacts or manifest of your Kubernetes templates. Might be a deployment service. So for that you can use a tool like Ansible, or you can like whatever is your best or whatever is your favorite language, use that and automate all the stuffs. But if you want to automate your deployment flow, Helm is one of the tools from Kubernetes community which manages the deployment releases and zero downtime deployment. If you are more into like, if you want to develop your own, you can also use Kubernetes API. So also labeling a node, if you want to isolate or schedule some of the nodes on specific nodes, you can check kubectl label nodes or labeling of the nodes in Kubernetes. Using labels, you can assign pods to certain nodes. Backup and restore. As I mentioned already, etcd is heart of Kubernetes. So if anything is down, if node is down, Kubernetes can recover. If API server is down, we can recover. But if etcd is down, Kubernetes cluster is dead. So we have to be very sure about making etcd is highly available. So we have to take periodic backup of that, and we should at least deploy 3 node etcd cluster on Kubernetes so that we are highly available. Also there are techniques to take backup of etcd cluster. We can directly take volume backups, but one should consider checking Reshifter, one of the famous tool, and Arc from Heptio, which are like etcd or Kubernetes cluster backup and restore tools. Also enable transport layer security for Kubernetes. Yeah, some of the tools when you are deploying your Kubernetes, kubeval is the single like it's a validation tool for your YAML templates. Then Kubernetes dashboard to view your cluster and health, Hipster and kubestate metrics to check the resources of your pods and what all they are consuming. So apart from that, it's been months we are running Kubernetes in production. Yes, there are some times that things don't work, but yeah, the community is awesome, and we can say that Kubernetes really rocks, and we have simplified our deployment process and we are using it effectively, which has helped us in reducing cost as well as deployment time. So yeah, questions?
Cool. Let's limit it to 2 questions as well. Okay, 1.
Since it uses etcd as the background store, have you run into any issues with the distributed nature of it, and that sometimes your truth is not true, like you have too many nodes down or something like that?
Okay, so you mean when we are running multi-node etcd cluster,
Yeah.
we run into issues that something isn't consistent?
Yeah, yeah,
Okay.
Consistency problems.
So you
It
face
uses Raft, I think.
You face this issue?
No, I'm just wondering if you do run into
Okay,
issues.
so first thing, if we are running 3 node or more than 3 node etcd cluster, etcd manages its own health, and if there is a restart of one of the node, etcd will manage the node which is restarting. The other 2 nodes will take up the cluster configuration and they'll keep it running. And whenever the 3rd node is added, it will be added using a flag called existing or new state. When you are starting etcd, there is one flag called start a cluster with existing, that is with existing state or new state. So by default, the highly availability structure is with existing cluster, and whenever the node is like restarted, it doesn't affect the health of the cluster. So if you want to avoid these scenarios, and I think etcd is a complex part about Kubernetes, you should consider learning some etcd-ctl commands. So that might help. If you run into issues, you can just say like etcd add member, etcd remove member, and all that.
Cool, thanks. We're going to have a short coffee break now for 15 minutes. Just before you run out, for those people who want fresh air and wind outside, the door over there, please. Try not to open both, because otherwise we're going to have a wind funnel, which won't be fun. And then secondly, for the open spaces later, there's a link on your flyer.
based in Johannesburg, but we've also got offices here in Cape Town, and we basically help organizations on their digital transformation journey. So we're a tooling company, but also do a lot of consulting as well. I've got a little bit over 20 years experience in the industry. 10 of those I've spent in Europe, working for large financial services organizations. I know we were starting to build continuous integration frameworks back in 2007, shortly before Paul Hammond did the Velocity 2009 talk, where he famously coined the term DevOps. And from that point onward, it just took on momentum and where it is today. So I'm going to talk to you guys about testing, as I think is one of the areas in DevOps that we haven't really addressed yet, and we'll go through some points today. So I travel a lot and talk to a lot of customers all around the country and abroad as well. And these are some of the testing experiences that I've picked up when I was traveling. Number one is ambiguous or no requirements. You know, that's something I see a lot, where, you know what, if you don't have clearly defined business requirements, you're not going to get very clearly defined applications on the other side of it. And it's something that we're going to talk about a little bit more detail a little bit later on in the presentation. But really, testing for some organizations is the last line of defense. It's the one thing they ignore the longest, and right before you have to go live, we realize, oh crap, we need to do some testing quickly. Let's quickly run a couple of scripts, get a few checks out, and then we deploy into production. Unfortunately, that's most of the time causing more issues than solving any problems along the way. And some of the reasons why we do testing so late in the SDLC is because of lack of environments, right? I mean, it's great from a dev point of view. We've started to embrace agile methodologies. You know, we've started to use Scrum, running 2 weekly sprints, and it's great, and we're knocking out new builds. But ultimately, testing is still lagging way behind dev from that perspective. Just because there is not enough test environments to test all the builds in, right? And also, test data is another issue that also, how can I say, hinder continuous delivery within software development projects. And then really, like I said, QA is the one discipline I think is not really agile yet. And also partly because a lot of the things that we still do is manual. There's still a lot of room for automation to be had within testing. So how good are you really at eliminating the barriers between ideas and outcomes? You know, I think on the one hand, it's actually unfair for organizations to be measured to newer companies, startups, and unicorns that's valued at $1 billion or more, where these companies have started from a clean slate, right? And they were able to build their technology stack, whereas a lot of companies and companies that you guys work for have a heritage, you know, of possibly decades that you've been in business through mergers and acquisitions, frames, and a lot of technical debt. So how do you compete with the unicorns of this world if you have all of that technical debt in your organizations? So it's really quite difficult. So we've come up with this thing called the software factory, because we do believe that every company is becoming a software company. And we do believe that it doesn't matter in what industry or sector you are, that software is redefining the way that you do business. I mean, long gone are the days we have brick and mortar stores and dial-in call centers. Nowadays, everything is done through your mobile devices and your PCs. So really, any organization needs to have a digital presence and a digital sales channel if they're going to grow or even survive going into the future. So really, the modern software factory is broken up into 4 key areas. Firstly, it's to create an agile business. And I think, you know, most people are on board with this one already. You know, you need to change the culture in your organization. And I think DevOps goes a long way in starting to embrace that cultural shift that has to happen in organizations. But then you also need to start building better apps faster. If you're going to compete in the industry, then you really need to be able to knock out new products a lot quicker. I do speak a lot with the financial services sector as well, and for them, their biggest threat is not the other banks. Say, for instance, for them, their biggest threat is coming from Google and Apple, because if you think about it with Google Wallet and Apple Pay, if you're going to start using those kind of services to transact, you're taking valuable information away from the banks. So the banks effectively becoming like a clearinghouse, right? So the whole thing around what's my users' buying patterns and what do they buy and sell and how do they transact online, all of that information now sits with Google and Apple, and they lose valuable insights into information that they can use to market and build new products and services towards. So it's really about how do we get those apps out a lot faster. And then security become a competitive advantage. I think, because we're in this application economy, digital threats and breaches is even more important than ever before, because once you hit the media that there was a data breach, that has reputational damages to your organization. And we actually see that about 70% of data breaches is actually coming from inside the organization, not outside. So again, how do we look at that? And then maximizing application performance. In DevOps, it's about monitoring everything, right? At every stage of the SDLC, we need to be able to monitor and bring those metrics back to enhance and improve the products that we develop. So those are the four main components of a modern software factory, and different organizations will start in different tiers of this. The one I'm going to focus on is building better apps faster, and in particular, continuous testing. So this is a pyramid slide of an actual customer of ours. And we've asked them, how much testing they do across dev, test, and the various type of components. And as you can see, that they do about 94% of their testing at the UI level. Only 3% at unit test level, and API testing is also a further 3%. We also know from our research that Forrester did that only 45% of UI testing is automated. And I think in larger organizations, that's even less, which means that there's still a lot of manual testing in organizations. And we can't really innovate at the speed of business if we only have one way to test our applications, and that's through the front end. There must be better ways that we can start testing a lot earlier on in the software development lifecycle. Think of it like building a car, right? You're not going to build the transmission, the carburetor, the engine, the chassis, put it together, and for the first time take it around the track and hope everything sticks together, right? No, you're going to build these components, test it to death, then put the parts together and take it around the track. So why don't we do it in software development? Why do we only wait till we have an end-to-end system before we start testing? We need to start to test at the component level. And that's really what our goals are. It's almost flip that picture on its head and say we have to do a lot more unit testing and a lot more API testing. Again, some of my peers here this week is going to talk about containerization and microservices. And as applications are being broken down from monolithic to modularized components, you need to test all of those components in isolation before you put them together and do true end-to-end testing. So really, we need to shift that. And the UI testing should really only become the last step in your process, the validation step of the user journey through my application, and not the other way around. So Computing UK did a study, and they asked self-proclaimed DevOps practitioners where they think the biggest bottleneck is, and surprise, surprise, 63% of them mentioned that keyway is still the biggest bottleneck there. So what are some of the challenges that face organizations around continuous delivery and continuous testing? So these are just some metrics that I've put up on the slide, might be a bit small to read, but 64% of defects can be traced back to unambiguous requirements. And I'm going to talk about that a little bit later on as well. 50% of developers spend their time fixing and finding defects. Because we're now in this fast-paced world, where we need to knock out new features all the time, we don't really get to test the quality of our applications till it's in production. Therefore, the developers are spending more time firefighting in prod than they're actually adding new capabilities to the products that they develop all the time. 70% of testing is still manual. We spoke about that. And 50% of time, the QA team are waiting for test data. Now, it's great to say, you know what, I'm going to take a production cut of my database. But again, few people know that production data only account for 20 to 30% of your functional test cases. How do you get the rest of your data? You still have to create it by hand or by Excel spreadsheet or whichever means that you find necessary to create the data. Again, adding further delays to your software projects. And then almost 80% of the time you wait for downstream systems, availability of environments. We spoke about that earlier on. It's great if you can knock out new builds on an hourly basis. Not so great if you have to test each of those builds in a dev test environment. So there's quite a lot of challenges that's holding us back. But before we can define what continuous testing is, we first have to see what it's not. So firstly, it's not just test automation. But by all means, it is a big part of continuous testing. It's not just continuous integration, but we do know that testing fits into continuous integration as well. And it's not just unit testing, although it is a big part of it as well. And clearly, it's not just done in a single environment. Again, we've come from this whole waterfall type project methodology where everything happens in clearly defined stages across the SDLC. And testing was one of those stages. Instead, in a DevOps culture, testing should start happening a lot sooner. Actually, you can already start testing at the requirements definition phase already. And if we define continuous testing, that's every stage of the SDLC to uncover and fix those unintended behavior as soon as that's injected into your applications or into your processes. So there's about 10 key elements of continuous testing. So the first one is about test automation. No surprise there. We do need to automate a lot more and be a lot more efficient in how we script our test cases. Secondly, simulate test environments. Now again, if you look at the developer community, they've been doing this for ages through mocking and stubbing, right? You need to integrate with a backend system. It's not available. You go and stub it. But what happens if you pass it over to test? They don't have stubs that they can test against. So that's where things like service virtualization comes into play. It's an industry-known term, service virtualization, not to be confused with server virtualization. And there we can simulate the behavior of backend systems so that when we hit testing, we can actually test as if those systems are readily available, whether it's mainframe, third-party, ERP, whatever that might be. And Jess Humble and David Farley, who wrote the continuous delivery book, they do say that the more often you test, the more often you release and test, the higher the quality of the products that you take to market. And then the access to the data, I spoke about that. It's great if we have production data, but what about all the rest of the data? What about those edge cases that we can't test with production data? What if we add new features? How do we get data for that? So really, data generation becomes a key part to that whole strategy of continuous testing. You need to be able to synthetically generate test data on the fly to support your specific set of test cases in order to drive this forward. And then start multi-tier backend testing. So this is what some people like to call API testing. I like to call it component testing. And really, again, the whole idea behind this is that we can't just do UI-based testing and wait for the UI layer before we do proper end-to-end testing. Instead, we need to start testing at each layer of the application stack as soon as we can. And through the use of concepts like service virtualization, whereby we can remove the constraints on the back, and we do API testing on the front, we can effectively isolate components within our application stack and test it completely independent from everything else, getting that cadence up that we so desperately need to keep up with our development practices. And then democratization of performance testing. Again, something that was exclusive in the world of performance engineering, and really we should start to look at things like performance automation through the development cycle already. If you look at load engines, you've got things like Locust, you've got things like Selenium even. They can do load generation, and also a JMeter. JMeter is a brilliant example of a tool that we can start creating load and performance scripts that we can execute even during development and not wait till we hit performance engineering. Because again, the longer we wait to uncover performance defects, the higher the cost of the organization, right? So the sooner we can solve those, the better to the bottom line of the company. And then all of those tools has to be integrated. And also when we start to create our end-to-end pipeline, through orchestration and automation, those deployment tools have to integrate with your test automation frameworks. The ability to do zero-touch deployment from the point where a developer checks in code into your repository to the point where the code is deployed to new test environments, test execution frameworks kicked off, and promoted to the next environment without any human intervention. That's really where we want to get to. That's sort of the nirvana state we want to achieve. And then also, the insight we gain from monitoring those applications become very valuable. You know, long gone are the days that application monitoring is just something done in production to monitor the ops teams and the production systems. We should actually start doing this a lot earlier on in our projects. I know Bank of America, Bank of Australia, for one example, they do not allow a code push into production unless they've proven that they have sufficiently tested it with their APM tool in order to understand the performance characteristics. In fact, APM tools can now start to integrate into your CI build systems to say, you know what, if a developer checks in your code, I'm going to stand up an environment, deploy the code, run a benchmark test, and if the performance latency is too high, I'm going to fail the build. How many organizations are doing that today? But most customers obviously are on a journey, and they do aspire to get there. I've spoken about waterfall projects, which is sort of where we started back 100 years ago, I think. And really, it was all about, you know, everything was well structured, well defined, and you had these silos. Christian spoke about silos as well this morning, and this is a typical example where code is thrown across the across the wall from the dev to test and from test to operations. And by the time it gets to ops, they have no idea what they're deploying into production. So really, we need to move on from there. So a lot of companies have started to embrace agile methodologies, whether it's Scrum, extreme programming, Lean, or even if it's a large organization, some of the newer frameworks like a scaled agile framework. But they're doing what I like to call water Scrum for, which is we are running 2 weekly sprints, but by the time we deliver the code to QA, they still take 2 months, 3 months to do quality assurance before that change is introduced into production. So all you've really done is you've shifted the problem from dev to test. You haven't exactly solved anything in the process. And this is really where we want to end up. We want to end up with what I like to call the in-sprint everything, whereby a sprint, let's say again we take a 2-weekly sprint, you use that sprint to define your user stories and your backlog, you do your development, and you write your regression tests, your automated tests, and the execution thereof, all within a 2-week. Because let's face it, when the guys from Scrum Alliance came up with the Scrum concept, and they said the definition of done is when you have shippable code, people didn't really take them seriously. Right? It's great to say I've developed the following features in a 2-weekly sprint, but I can't deploy it because I haven't yet tested it. Right? So really we want to get to the point where indeed after every 2 weeks we have shippable code that we can potentially deploy if we so choose to do so. And that's really where we want to end up. So let me just take a quick simple view of continuous testing, and then I'll wrap up with that. So at the top, you have all the continuous everything phrases. You know, you've got your continuous integration that happens in dev. We've got continuous testing, continuous deployment has also been discussed, and continuous delivery, all about delivering those features into the hands of your customers. But the continuous testing is, like I said, the one where I think we've neglected it the most over the years. So within continuous testing, there are 5 key areas that we need to look at. So if we start off at the requirements modeling phase of a project, typically business analysts will use Word and similar tools to define the user stories and the use cases. But let's face it, language like English is great at writing poetry, not so great at defining requirements. It does leave room for a lot of ambiguity in how you define these user stories. And really what we need to do is move towards a model-driven way of defining your use cases. So if you can start using things like flowchart diagrams, or even I've even seen some people starting to use mind maps as well to define your user stories, that's visual, it's easy to interpret, there's not a lot of ambiguity left to interpretation. And also, there's a nice side effect of all of this. Computer systems are great at modeling, not so great at interpreting language. So if we can start defining our user stories in flowchart diagrams, we can actually use computer systems to start analyzing those flows, if you will, throughout your application to understand what are the least amount of test cases that I need to derive from this user story in order to fulfill that particular requirement from a testing point of view. Because let's face it, from a testing point of view, what's the easiest thing to do? There's a new feature request. We don't go and re-engineer the test cases that we came up with last year. We add new test cases. So after a while, you get to a point where you literally have hundreds and thousands of test cases, and it's just impossible to maintain. Never mind the over-testing that you get from running all of these test cases all the time. And again, those are the kind of delays that is making it very difficult from a QA point of view to accelerate your software development practices. From a development point of view, I spoke about unit testing earlier on, and TDD, test-driven development, is one of those areas that we can really look at. From a testing perspective, the ability to write your test cases before you actually start writing a line of code. Now, I do know that from a dev point of view, it's very difficult to do. I know I'm working on some open source projects myself, and I always have to catch myself starting to write business logic before I actually start writing the test cases. So once you've written your test case, you then start creating your application. Once you validate that new feature, you then go back and you refactor your code and make it more performant and restructure your application logic. And then you rerun your unit test again to ensure that it still passes all the checks. And that's really the kind of method or process that we should start to adopt when we do software development. And then from a test design point of view, now again, this is linking back to the modeling and the requirements phase. Again, if I do model-driven development, I can use those models to derive a minimal set of test cases that I need to fulfill a particular requirement. And we need to do that in testing because there's no way we can keep up with the rate of change coming out of dev if we don't streamline our testing principles as well. There's one of the big credit card companies in the US where every time they make a functional change, it takes them 5 business days or 5 physical days to understand the impact that change has on their existing test cases. Can you really afford to spend 5 days understanding the impact before you remediate those test cases? Not really. We spoke about test data earlier on as well. You know, it's great. Really, we need to get to the point where we can intelligently, synthetically create test data to support our test cases. And what's really cool is if you can link your test cases with your test data so that you know that for these particular test cases, this is the kind of data that I'm going to need. Again, allowing you to streamline your whole quality assurance process by only making available what's needed, effectively stripping out all the waste. And again, in lean practices, we call it the work in progress, the WIP that you need to reduce in order to achieve efficiencies there. And then we need to automate a lot of that. You know, 45% automation is not clearly good enough if we're going to stay current with the rate of change going forward. And then from a test execution point of view, really test environments. I spoke about virtual environments or service virtualization earlier on. And this is a key part to this. You know, we need to be able, even from a developer point of view, say, okay, instead of mocking, I'm going to actually create virtual services so that when the devs hand over the code to QA, they can actually start using the same virtual services that were defined by the devs to start testing the application a lot sooner as well. And again, further removing those delays. Bank of America in the US, they have this process whereby every time there's a code check-in, they stand up a new environment and they deploy their core banking application onto this new environment. And they use service virtualization to effectively mock the backends for their 5 core transactions. So those are like login, pay beneficiary, check balance, and so forth. If any one of those 5 core banking transactions fail, builds fail as well. They can't do that without something like service virtualization that will allow them to simulate those expensive backends all the time. And then through your test automation engines, there's quite a few of those. You know, if you look at things like Eggplant and Selenium and Xenorex and UFT, these are all typical test execution engines that we need to start looking at. And really, as I said before, it's not just looking at the front end. Do protocol injection at an API layer, whereby we can test these components in isolation as well. And then monitoring is all about analyze, learn, and update the model. I had a nice use case the other day where, you know, what if you develop a mobile app and you think, okay, the layout of everything seems logical, but your target audience or your user base are people that commute in the mornings. Now, again, in South Africa, maybe not so much, but certainly in the UK, there's a lot of commuters on trains. And what happens is if you're on the underground train, you know, you hold on with one hand to the rail and your phone in your other hand. Now, if everything that you need to do from the phone's layout is on the opposite side of the screen, you're going to effectively struggle to navigate the application. That is real tactile feedback that becomes part of testing, because once I understand those changes that I need to make to my application, the model that we spoke about during the requirements modeling stage, we can easily go and update the model. And by doing that, we can instantly run an impact analysis to understand which use or test cases are impacted by this change in my design. And that way, we can reduce the number of changes considerably in the process as well. So those are the 5 key areas that we see as part of the continuing adoption and evolution of organizations' continuous testing frameworks. So really, can you afford not to do testing? I mean, it's great to say that, yes, DevOps brings speed, but speed without quality can ultimately lead to disaster. 2 out of 3 business leaders say their company's future absolutely depends on the quality of the software. Because let's face it, the software that you take to market is the storefront of your organizations. It is the brand of your companies. And if your customers are experiencing a negative brand, a negative experience, that's going to impact you in the long run as well. So with that, I want to say thank you very much. Thank you.
Okay, next up is Devet, and he's going to teach us about 107 things that he learned when applying for jobs. Okay, cool. Actually, 107 jobs, right?
The things I learned from applying. All right, can you hear me? Great. Well, I was 32 years old and found myself in a little bit of a predicament. I was coming off of 15 years in the nonprofit community development space and wanting to transition to a career in writing code for profit. And one of the challenges there was that the average employer did not share my optimism about how my previous work experience would prepare me to provide great value on their team. And so I probably could have easily walked into, done the average amount of effort, applied 5 places, and take a absolute entry-level position somewhere, and gotten a job writing code. But specialized medical issues, come up with better than average results. I had to put in better than average effort, and I ended up applying at 107 jobs. I have the spreadsheet to prove it, and I want to share with you a little bit of the things I learned in that process. I widened my net to remote jobs, so I'll share a little bit also about remote jobs. Here's the overview of what I'll share. The strategy I followed, what you should look out for, who I think remote work is ideal for and who I don't think it's ideal for, some of the pros and cons of remote work and misconceptions of remote work. So I'll touch quite a bit on remote work, but tell the story and how it ends. Also, I've given this talk once before, but it has a different ending now, so it's a new talk now. So, yeah, this is the beginning of this journey where I picked the story up. When it's time to go hunt for the job, my wife told me, well, Devet, it's a numbers game. You're going to have X amount of employers say no to you for every one that says yes. So if you just apply at enough of them and apply at a lot of them, you will get enough yeses and then, get a job that you want. And I told her, no. The tech industry, it works differently. If I just have the right tools on my resume that I've learned, so there's all these hot JavaScript frameworks, if I can just figure out which one to learn and put on my resume, that is going to help me get a job. But Devet, what are you doing? It's a numbers game. You're supposed to apply at X many places, apply at a lot of places, and the exact same. She would like me to make clear that it is the exact same thing she said, and actually me is you can't code your way out of a sales problem. And I don't know if it's cool to use DevOps as a verb, but you can't DevOps your way out of a sales problem. And if you're in this room, you probably identify with me where you've got a track record with computers and you've got a good track record with computers. That I know that if I sit down with a computer for long enough and focus on a problem and don't give up, eventually I can make the computer do what I want it to do. And so in wanting a really great job, I figured, okay, that I know that I as a person can follow these steps and get there. But finding a job is not an engineering problem. It is a sales problem. You are trying to sell all of your hours to one buyer to buy them from you on a permanent basis. And the same can apply for getting contract work or different kinds of jobs. But yeah, and if you're at a place in your career, maybe a bit later in your career, where finding a job with several years of experience becomes really easy for you, still I think there's a challenge for you to look at the act of sales not as a sleazy thing that people try to manipulate others to do things that's only good for them, but it is a transfer of idea, and whether it is you're trying to convince that person that you should be using Kubernetes or continuous integration or testing, if you're trying to convince somebody of that, just putting your head down and spending a couple weekends and building the best demo could be valuable, but I would appeal to you that you need to look at the fact that you're dealing with a sales problem, that you need to transfer this idea to somebody and think of their perspective and think of their needs and try to communicate to that. So yeah, I had to accept this. Acknowledge the competition. So this is, again, this gets vastly different with how many years of experience you have and what you've been doing. But especially in remote work, you are competing with everybody in the world that is qualified to do this job to do it. So you're going to have to try hard because there's many people competing with you. And the same within Cape Town or within the city you're living in. If there is a company that either has excellent work culture, the managers treat their employees with respect, or excellent compensation or excellent, benefits or something, there's going to be more competition for those jobs, so you might have to work a bit harder to get to those. Write down what you're looking for. So there's a lot of, it is an emotional thing. You might like to think you're purely analytical and just will look at the facts, but it is an emotional thing to think of, okay, do I want to spend most of my life, waking life, with this group of people working on something? And so on. So emotions can sway you this way or that. So write down what you're looking for. Write down what compensation, what is important to you, and so that when the time comes to decide, okay, am I taking this job, am I not, that you've got something to look back on. Well, does it match what I'm looking for? Presentation matters. Again, we've all met the guy who would say, no, I've never applied for a job. Jobs come to me. Well, sure, that could work for you. I'm of the opinion you could do better if you focus on not purely just on your skills, which is very important, and you have to always keep learning and be able to deliver good value, but also presenting it in a way that somebody can understand what it is you're offering. So I paid somebody to professionally create this CV for me, and they actually are a really good graphic designer. So I had to ask them to make it just a little bit uglier than what they usually do, to make it look like somebody who could code would be able to, do it themselves. So yeah, went and updated LinkedIn and website and all that stuff, and it's important. If an employer is trying to figure out who you are, that's all they've got to go on. Got a professional headshot taken, and got some endorsements from people I've worked for. So prepare for a sense of failure. This is important to grow strong on the inside, and just accept it, that you're going to be told no. And also, if you cast your net wide enough, if you apply at 107 places, you could even find one or two that turns you down in a not so nice way. X amount of no's to get to a yes. Get organized, track your progress. So I made a spreadsheet. I'm not going to share it because there's personal information on it. But if you wanted my column names and wanted to chat about, okay, how did I end up doing this, I'd be happy to share that. Also, I happen to now work for SalesLoft, which is, as luck would have it, a software specifically for this sort of thing, for tracking a bunch of people you want to contact. Also, if you happen to be working on building a product and you're hoping the sales team would sell more of it so that your work can have more impact, mention to them that you've heard of SalesLoft. As soon as the sales manager figures out what it does, it's actually pretty easy to sell. It's like, well, this will help your salespeople sell more stuff. Okay, cool. We'll write the check. What to look out for. So you don't want to, another thing my mentor said a lot, it's a lot like dating. You don't want to come right out on the first date with, all these big topics. You want to get to know each other a bit. But there's two topics that I think you try and bring up a bit earlier, is time zone and compensation. Because I ended up wasting a bunch of time on this, where I would get into an interview cycle with a company, and I like them, and they like me, and we get down the road, and by the end, we figure out, well, no, they need somebody to work in their time zone all the time. Or I figure out at the end, they're wanting to compensate really bargain basement prices. And so I try and figure that out maybe on the second interview, or maybe first interview if you already had a couple emails. But I mean, you decide. So who remote work is ideal for? I think it's ideal for parents. I get to go get my daughter from preschool every day and have lunch with my kids. That's really great to work around that schedule. Also intrinsically motivated. If you need somebody sitting next to you to help you to not open Facebook or watch cat videos during work hours, remote work might not be ideal because that person's not there. Also, if you like to travel, I've had coworkers without kids who would travel all around and work from different places, which that seemed really cool. Also, non-commuters and non-immigrators, if you really don't like commuting for some reason, or you want to work for a foreign company and really don't want to emigrate, remote work could work for you. It's not ideal. I think it's not ideal if you're living alone. Yes, there is a lot of interaction with Zoom or Skype or Slack or whatever you're using, but there still is a certain amount of just alone time with the computer in a fairly quiet room sometimes. So if you're living alone and working remote, I'd consider a co-working space where you're at least around some other people who's, you can interact with during the breaks. If you like to regularly go out at night, I'd love to regularly go out at night, but I've got 3 kids, so I don't. So the time zone thing, the company I work for is based in the US, so the fact that I've got a couple meetings in the evenings here and there doesn't bother me. I can go out anyways, unless I get a babysitter. And so yeah, consider the time zone requirements there if you like the nightlife. And if you want to optimize 100% for learning, which is a great thing to optimize for, especially earlier in your career, but anywhere if you want to keep up with the rapid change, learning is very important. I think the most optimal place to learn a lot is sitting in the same room as the experienced people you want to learn from, so that if you see them watching cat videos or you see them go get a coffee, you can quickly stop them and ask them a question or something like that. Where remote, you have to do a bit more guesswork on when might be a good time to interrupt, or use asynchronous communication where it might take them longer to get back to you. Still, I've learned a ton working remotely. It just isn't as optimized for learning as fast as possible. Some misconceptions about remote work. Hold on, gotta make sure I don't eat into your lunchtime. I don't think you guys would enjoy the talk as much if I start taking into your lunchtime. No relationship with your coworkers. You just don't know these people. It's just you and your computer. It's not true. Both remote jobs I've had, there was a focus to fly the team. Okay, at the one place, everybody was remote. Fly the whole team together every 6 to 9 months with the focus of spending time together. Or where I work now, fly me to the office every 6 to 9 months to spend time together. This is a summit, and here's a movie and discussion night with pizza. Yeah, you still get to know the people. You miss them because you don't get to see them in person every day. But yeah, you do get to know them. You're on your own time all the time? Not really. There's still. I have a weekly one-on-one with my boss. I like to put pairing time, pair programming time on the calendar so that I make sure it happens with my teammates. And those things you can't just willy-nilly, plan 5 minutes in advance. So there are some certain things that has to happen. I tried one time to go camping and not take time off. Remember that intrinsic motivation I told you about? That goes away when I'm camping, man. If I'm next to the river with the birds chirping in the air, I didn't want to do any work. And I've tried working in the car. I had a cornea transplant there. You see me with the eye patch. I have had meetings from the car. It's just a bad idea. It didn't work that well for me. Now, I'll preface that with I did just, in the last couple of weeks, work from Florida. But I would go to the library. And my wife was spending, and kids was spending time with the kids' grandparents, with my wife's parents. And they would go to the beach for the day, and I might join them at the end of the day. So there's still some nice freedom there. But I didn't try and work from the beach, because me personally wouldn't get work done on the beach. And yeah, maybe I'm getting old, but my wrist hurts if I type on a flat keyboard the whole week. So I've got this ridiculous keyboard, and I've decided I don't need 3 monitors. I only use about 2. I once heard people complain about a hissing sound during an interview and bought a mic that they can hear me well. So I personally like to just be at my desk getting a real work done in a real way. The picture of the guy just traveling everywhere and working from everywhere, yeah, I've done some of that, but ideally at a normal place of work works best for me. So the first ending to the story is that at the end of the 107 jobs, I got a job at GitLab, and I really liked working for them, especially since I no longer work for them. You know that I'm not just saying this because they're paying me, but they are a great place to work for. It was a great job. I learned a ton. I would totally recommend working for them. If you want to chat about that, let me know. And then after a year of working for them, one of the 107 places called me back and said, hey, we had this position open up that could work in your time zone. Would you come apply for it? So then I got the actual dream job that I'm really happy about and really thankful for that I have now, working for SalesLoft. And so, yeah, it wasn't a clear fairy tale ending if you put in all this work and you get the ultimate job you want immediately. It took some time to get where I'm like, wow, I don't feel any need for any career change anytime soon. So, yeah, that was my journey of applying at 107 places, and it paid off for me. So, oh, I had a quote to leave you with. There we go. This is by Theodore Roosevelt. It's not the critic who counts, not the man who points out how the strong man stumbles, or where the doer of deeds could have done them better. The credit belongs to the man who is actually in the arena, whose face is marred by dust and sweat and blood, who strives valiantly, who errs, who comes short again and again, because there is no effort without error and shortcoming. So if you try hard, you're going to fail. So go out and fail, because it's required. Any questions?
Any questions?
Hi. You talked about optimizing for learning.
Yes.
I find it kind of interesting. I think maybe your point pertains particularly to working with a team, because you're kind of isolated and you're not in the same room with those people learning.
Exactly.
But what about if you were working remotely in a team of more or less just one or two? You know, how does that change the optimization for learning? Because surely then you're having to learn a lot more because you're more of the puzzle pieces.
Yeah, I could definitely see that being a different dynamic. I think there comes a point, if you're consulting, to build it into your budget that you pay somebody more experienced than you to come sit next to you, I don't know, once a week or something. Yeah, I guess if there are less people there, if there are only 2 people on the team anyways, then being in the same room as them is less important. Yeah, I haven't thought about that as much. Good question, though.
One more question.
How did you select your 107 companies, and kind of what was the pace of doing so? Did you kind of batch them up and take lessons learned from earlier ones to apply for later ones?
Great questions. I'd say yes, I did take lessons learned. So I knew Ruby, so I was looking for a place that is using Ruby and has a job close enough to programming, QA, support, whatever. So that's how I selected them. I just looked for any company using Ruby who ideally hires remote people. How I batched them up, I made a list of them, and batching some jobs was more efficient. So just making a list, you can just spend the time making the list and not take them. But I was very fortunate to have a mentor who would let me BCC him on the emails, and he would give me feedback on how I could have better approached them through writing the emails. And I think doing the interviews was very important, because getting better at the act of interviewing was, I think, paramount in getting success at the end. Just practicing. Oh, and one tip, I know we're over time. One tip, if you are practicing for an interview, is that try this you take the role, as you prepare for the interview, you take the role of the interviewer, and your friend or spouse or coworker or whoever's going to help you practice plays you. So I would play employer, and the person practicing with me would take the vet, and we would have the interview, pretend to have the interview. So I really get in the head of the person who's going to make the decision on hiring me or not, which I think helped.
Thanks very much, David.
Thanks.
It's lunch next, and I don't want to be the 2 today and 2 tomorrow. So first up we have Ruben telling us about the state of upspin.io. Thank you.
Thank you. Hi. Email. Declared dead countless times, going strong since the 70s, and probably not going away anytime soon. Many factors contribute to this success story, one of them being federation, based on standards, allowing anyone to participate in this system, meaning the weirdo running his postfix behind his ADSL with the dynamic IP up to the R&D department, having to necessarily run their servers on premise, up to the big players we know these days, basically running all our communication via email. So another factor, in my regard, is the simplicity of the system. Over the phone, I can read this email out to somebody and they will be able to understand that notation. It might be the receptionist somewhere or so. And they also understand concepts of email. So if the office is, for instance, down, they will understand, okay, my CRM system won't receive emails anymore. And, sorry. They also understand concepts that their mobile device will then, for instance, also be able maybe to receive emails still. And from the CRM vendor's perspective, for instance, they will be able to determine, okay, we understand email, it's simple, it's robust, we'll make the decision to make it an integral part of our CRM. So what if we could share information in the same way? Just access through a simple global namespace, instead of being downloaded from one silo to be uploaded to another silo, we all know this. Duplicated or synced all over the place from machine to machine to machine. What if files could just be accessed instead of copied all over the place? Manually, programmatically, through a simple address like this. End-to-end encrypted also. We all need security. Enter Upspin. Upspin looks a little bit like a global file system, but its creators define it as a set of interfaces and protocols and components from which an information management system can be built. One of them being Rob Pike, I don't know if you know him, one of the creators of Go, and joining him other prominent figures of the Go community, and also explaining why everything is basically nowadays implemented in Go. And yeah, they still encourage people to do their own implementations, but yeah, everything is currently implemented in Go. There is a client library, and from the client library there are different tools, one of them being Upspin command line tool, here the Upspin UI, which you operate from the browser. And these tools provide you with the necessary actions to set up and use and yeah, manage Upspin. This tool, for instance, will guide you through the process of creating your private key and your public key, registering with a public key server, and also things like explaining the importance of seed to recover your key later on if necessary. Optionally, it will also help you set up your own server. Currently, the implementations support Google Cloud Storage as a backend, AWS S3, and also a local disk. You'll most likely implement your own server or install your own server on one of the cloud providers. Let us see how one of the user experiences can look like. So this is the view from Upspin FS, one of the standard tools as well, which uses Fuse to create a mount point. I don't know if you guys know Fuse, but basically what I've done here, I've used Upspin FS to utilize Upspin, the Upspin namespace in my operating system. Here my standard file manager, any application for that matter, can access files through that address. You can see here my email address, subdirectory I've created, DevOps days, in which I'm hosting a text file and a PDF. So what happened here if I wanted to access a file in the system, for instance, with this address here, I would then ask a key server, okay, give me the information for that address. It will answer with the public key of that user, and also give me here a directory server. In this case, dir.upspin.io. Then me as a client, or my implementation, would then look up the file name at that directory server address, and then I would get back storage servers and block references. I would then go to that storage server and ask for these block references. And important to note here, the client only then starts decrypting the files on the client side, hence end-to-end encryption noted earlier. So a little bit about the directory server and the storage server. Firstly, the key server is known to all clients. So there has to be some kind of combining element telling everybody what is what, and that's the key server, and it's currently one address hosted redundantly. And the directory server and the storage server can be hosted in one, which is the current way to go, but it can be separated as well. So you can separate the directory server and the storage server. You can either use it for yourself or host multiple users on it, or maybe use it for singular purpose, like for a camera or something. So the whole system is implemented only with these few methods. That's very interesting from an implementer's perspective. It's very simple and understandable. By default, nothing is shared, everything is encrypted. So if a user wishes to share something, she would then drop an access file, a clear text file, with this kind of notation here. These notations are supported as well. So here, abbreviated with writes instead of read, R, for instance, uppercase, lowercase, doesn't matter. Groups are supported, here family. Group files are hosted separately. Wildcards are supported. There's a special group called all, and also the lower notation is also valid, meaning wildcard, a simple domain. But for this to currently work, you would have to store your files unencrypted, which defeats the purpose. You have to be careful about that. They're thinking of maybe implementing support for organizations who want to share files over an organization, but that is currently not the case. Encrypted. Interestingly, the plus notation is allowed. I don't know if you guys know this. With your Gmail account, for instance, you can do this. Andrew Gerrand has implemented server client actually streaming camera data, for instance, as a proof of concept. I don't think he's currently publicized it. And what I found interesting is that symlinks are supported as well, symbolic links, and not only within your tree, but throughout the whole namespace. So you could symbolically link files across the whole global file system. Then the question of maturity. So on the mailing list, we already received a couple of these mails with action required in the subject field. So the creators are not tired also to underscore that things change and with drastic consequences for your data. A couple of times now, yeah, this did happen and will most likely happen again. So why bring this up here? This rather experimental system. We all have information to share. We all are trying to understand underlying principles of systems to then find a programmatic approach to our problems. That's okay, but what I found very interesting in this case here was, okay, we always face this question of, this vague question, is my data secure? Okay, what am I going to do with that? Also, a variant of that, where is my data stored? And I find that with the separation of the directory server and the storage server, with the introduction of a global namespace, and also with end-to-end encryption, these creators have found answers to those questions. So I think it's worthwhile looking into it, and you can check out the documentation, which is excellent, on upspin.io. If you live in Twitter, that's the handle. Read Rob Pike's manifesto regarding what the initial motivation of the system was. So why I'm also speaking here is, if you need a sparring partner to test this, write me an email, I'll hook you up. Even if you don't want to set up the server, please just contact me, I'll give you an account. Thank you very much.
One, two. Can we get a mic change, please? Mr. Storm, take it away.
Hello. So, security for everyone. Unfortunately, there isn't a one-size-fits-all solution for everyone. But I'm glad this got your attention. And this is aimed at people like us and mostly our colleagues. We all have, as developers, the keys to the digital kingdom that is our company. Okay. Did I push the wrong button? I've gone to the end of my slideshow. This is going great. How do I even PDF? I'm just going to show you my entire slideshow. Why not? Let's begin with threat modeling. We all do this intuitively. We have a good sense of how to keep physical objects safe and secure. Your keys, your phone, your wallet. You know when it's reasonably safe to leave it lying around, when you need to take extra precautions, be extra vigilant about it. You know the difference in securing your wallet and, say, your home. Like, these are very different things. But when it comes to the digital world, this doesn't translate directly. This is just the definition I've copied from the EFF site on self-surveillance defense. They have some pretty good resources. I'm not going to read this out loud. You've probably read it while I was rambling. Essentially, you need to ask yourself these 5 questions. What am I trying to protect? Who am I trying to protect it from? How likely is it that an adversary will compromise this? How bad is it if I fail to protect it? And what effort am I willing to go through to keep this safe? That last question is especially important because the more difficult you make security for yourself and for your users, the more likely they are to, one, not bother, or to circumvent it in ways that you did not intend. As an example, let's say I want to consider my emails. They haven't gone away. This was said just now. Slack hasn't reduced the amount. Who am I trying to protect it from? Spam bots, script kiddies. The point here is not an active attacker, not a targeted attack. How likely is it that an adversary will succeed? Well, that depends on the precautions that I take. I'm not going to go too much into detail in this point because of that. How bad is it if they do? Well, I have email going back decades. I've discussed some pretty sensitive things. It would be catastrophic if that was to be made public. How much effort am I willing to go into this? Obviously, therefore, significant. I have a strong, unique password for my email address. I use two-factor auth. It means it's a pain because I don't actually know what my password is when I want to log in. So why is this a good idea? This is my email address that has been redacted. Troy Hunt maintains a site called haveibeenpwned.com where you can see if your credentials appear in a leaked data breach. It's not obvious from this slide, but my email address appears in 9 breaches that contain emails. This includes LinkedIn and Dropbox, services you probably use. This is just one way that you can be aware of when your data is breached. Obviously, if you lose access to your account and you find you can't log in or your friends are telling you you're sending them weird messages, that's a slightly more obvious sign. This would be useful to keep track of, and I think they have you can subscribe to notifications if your name appears in a new breach. But this is just to demonstrate one of the inherent risks in password authentication is credential reuse. Coming up with strong passwords is really difficult if you need to use a different password for every service. You can't remember it. I used to be really bad at this myself. I had a set of tiered passwords, you know, your simple one you use for your desktop because it's physically secure. It doesn't need to be really strong. You can type it with your eyes closed. Slightly more secure password when they say you need a capital letter, you need a number. Slightly more secure for that when you want to protect your email. Sign up for a new service. Reuse the same password because you want to remember a new password. New service has different password requirements now. Your passwords don't work. Some of you may know where I'm going with this. Enter password managers. They make your life so much easier. Generate a unique, strong password that, what's the word I'm looking for, satisfies all of the inane password requirements you get. These are just some suggestions for ones that I have used personally. These are all really good. There's a debate going on about, do you use online password managers? Do you use offline password managers and handle like distributing them to your devices yourself? Do you handle backup yourself? That's something you need to ask yourself. And once again, go back to your threat model. Are you worried about an adversary that would potentially have access to cloud services or not? I can't answer this for you. But really, use a password manager. Even LastPass was hacked. People were like, don't use LastPass. I think you're still better off using a password manager, even if it was hacked in the past. These people know what they're doing. They take precautions. Yeah. Now, when password manager can't, obviously you need to secure your password manager somehow. You use a password. You can't protect it with itself. So enter well, the slide. It's good to note that passphrases are better than passwords. These are technically the same thing, but semantically have different meanings. Passwords are short, complicated, difficult to remember. Password phrases tend to be 5 or more words, no relation to each other. They don't need special capitalization. And that combination has significantly higher entropy than the passwords you're typically used to. There is a solution for generating these passwords called Diceware. I think the website is diceware.com. It has instructions, it has a word list. Effectively, you roll a bunch of dice, choose a word from the word list, repeat this step until you have enough entropy in your desired password. It's actually pretty easy to remember that XKCD comic is the horse battery staple one, if that sounds familiar. Otherwise, look at the comic, it's pretty funny. I mentioned I use two-factor auth for my email. It's kind of annoying when you have to wait for an SMS to log in for something or unlock your phone, open up Google Authenticator. These are all good things, and if you don't need to do them too often, it's not actually that annoying. If you do have to do two-factor auth significantly often, getting a FIDO U2F device is amazing. I have one on my laptop. You can't even see it because it just fits entirely inside the USB port, unlike the picture here. You just tap it when you get to a two-factor auth prompt, and then you proceed. It's great. It's practically invisible, which is the kind of solution I like. Better security and actually no visible user impact. Unless, of course, I don't have my two-factor auth device on me. But you can always fall back to an authenticator app or backup codes. And really, if you use two-factor auth, you should have backup codes printed out, kept somewhere safe. My phone got stolen. I got locked out of all of my accounts. I had backup accounts for everything except AWS. And I was fine. It was backup codes. And you see, this is actually a numbered list rather than a bulleted list. Those are my order of preference for two-factor auth solutions, if you had to choose one. Preferably something that doesn't include SMS because identity fraud, SIM swap fraud. If you do come up against a targeted adversary, those are easier to circumvent than the above options. Environment variables, I used to hate them. If you've ever seen a Django crash screen, you see it dumps all of your environment variables. It has stuff to asterisk out anything that contains key, password, a couple of things that look sensitive. But think about every other application that you run from your console has access to all of your environment variables. Needlessly so. Enter envchain, which is this great thing that I've included the GitHub URL. And to give you a little example of what that looks like, if I dump all of my environment variables and look for AWS, there's nothing. If I tell envchain I want everything in the AWS namespace to be available to this command, and then run env to dump everything, you can see there's my AWS secret key and AWS access key. Of course, this is a little bit cumbersome if I want to write envchain AWS, some AWS command that requires a thing. So I just created an alias for those 3 words. You'll see if I run a S3 command ls without the alias, and that's what the backslash is for. It tells me it's not configured. Because I have the alias, run it again, S3 command ls, you can see that there's something in that bucket. And the nice thing about the alias is that it means my command completion works again. I really like completion. You can see I have a fancy shell that implies that I like doing things with my shell. FDE, I mentioned this because really it's just a checkbox when you install your operating system these days. Unless you use Windows, then you have to pay for the expensive Windows. But really there's no noticeable difference having it and not having it. You should really just have it. backups. This was a fun slide that appeared when I was having slide issues. I mentioned having backup codes, but also have backups of your data and think about how you are securing your backups. Because part of information security is being able to access your data when you want to. And if your data is gone, there's no way to access it. So that's not secure. I think we've got time for questions.
One or two questions? That was loud.
Hi. I noticed you didn't mention 1Password as part of the password managers. Do you have any opinions on that, or is it just
I've got nothing against it. I just haven't used it personally. I think I only listed options that I'd personally used.
Okay, cool. Thanks.
Any other questions on security? None. Cool. Thank you very much. Thanks, Storm.